I want to solve this differential equation using the Laplace transform. So the differential equation y prime prime, so the second derivative of y, plus alpha squared times y is equal to h, where alpha squared is simply a coefficient and h is some random function that you don't really know anything about it, except that its Laplace transform exists and that it is a piecewise continuous function. That's all we know. And we have the initial condition, so y of 0 is equal to y prime of 0, which is simply 0. So y of 0 and y prime of 0 are both 0. So if you take the Laplace transform of everything, remember your formulas, you will get s prime capital Y of s minus s times y of 0 minus y prime of 0 plus alpha squared times capital Y of s is equal to capital H of s. Okay, that is our function s, and that is the formula for second derivative. And here we have our alpha squared times y. So now we apply our initial condition, so that is 0, because we have y of 0 and y prime of 0, and so we are left with s prime, s squared times capital Y plus capital Y times alpha squared is equal to capital H. So now we can solve for capital Y, we get capital Y is equal to capital H over s squared plus alpha squared. And so we can write it as capital H of s times 1 over s squared plus alpha squared. And so to solve that, I mean, we won't really solve anything, but we will use the convolution theorem to just write it in that form. That means that, yeah, remember that if we have like capital Y is equal to capital H times something, we can we know that y is equal to the convolution of the inverse Laplace transform of h. So it is equal to the convolution of the inverse Laplace transform of h and the inverse Laplace transform of the other stuff that is here inside. So in this case, we don't know exactly the inverse Laplace transform of h because we don't know anything about it, but it is simply h. We know that because at the beginning we had h here. So we write h, and the inverse Laplace transform of 1 over s squared plus alpha squared. Well, remember that as written here, 1 over s squared plus alpha squared, we can write it as 1 over alpha times alpha over s squared plus alpha squared. And so you take it to 1 over alpha in front because it is a coefficient. And now here you have alpha over s squared plus alpha squared. And the inverse Laplace transform of that is simply sine of alpha g. Okay. Yes. And then as I said, we keep our 1 over alpha here in front. And so we can write it like that. So we have the convolution of h and 1 over alpha times sine of alpha g. Yes, and if you don't know about the convolution, look it up on the internet. It's yeah, but it's not the point of this video. Yes.